Let's solve this problem right here using a technique called a bar model or bar modeling. It's about a fourth grade level problem, and it's really not very hard. Probably don't even need a bar model to do it, but the idea of the bar model is it really helps the kids to visualize the relationships between the numbers a lot more easily than just say looking at the numbers themselves. So we're going to start off by making a bar. There it is. And you can see I've got it dimensioned for the length of the wall, 78 feet. And so from here on, we're just going to sort of dissect the problem a little bit and take it one chunk at a time. And the first chunk I see is that one, 78-foot wall. Got that already, no problem. So then what? He painted 19 feet the first hour. So we're going to then consider that. So now we have to look at our bar and figure, that whole thing's 78 feet, where's 19 going to be? Yeah, it doesn't have to be too accurate. Let me just make a mark right there. Let's call that 19 feet. So that's his first hour. Okay, now the second hour, he did twice that much. Speeded up the job a little bit. So the second hour, let's represent that with another 19 and another 19. And they're all 19 feet. Okay, so now the question is, how many more feet must he paint? So pretty clearly, they're asking for how much is left here. And the idea now is kids will be able to look at this and have it be fairly intuitive that if they take these 19s away from 78, whatever's left, that'll be the answer. So let's go with 19, 19, 19. I can tell you that, added up, that gives you 57 feet. So then if we take 78 minus 57, and again, the idea is kids should have a really good shot at looking at this and saying, oh, yeah, it is a subtraction problem. We take this away from that. What we get, in this case, is 21 feet. That's the answer to the problem. That's how many feet you must paint to finish the job. Okay, hope that helped a little bit. We're going to tackle another problem next. A little harder than this one, maybe. Okay, new problem. A little harder than the one before. First fact, number of oranges is 3 times number of pears. Let's just make a bar for oranges. Don't know how long to make it. So we'll just go, call that oranges. Oh. Okay, now pears. Let's make a box for pears. But we know that the number of oranges is 3 times number of pears. In other words, the pears must be a lot smaller than the oranges, the number that is. So pears are something like that. In fact, we even know that exactly 3 of them would fit in there. So let's take that off. I erase that. Let's see if I can't get something back in there. Alrighty, so we know 2 things. That represents the number of oranges, and below it, we have the number of pears. Okay, next fact. Total number of apples and pears is 184. Okay, well, we know how long to make the pears, not very long. So keep in sync with that. Let's just make apples. Don't know how long to make that, doesn't matter. Just guess. There's apples. Now add pears on there. We know the total, 184. All right, Fact number 3, total number of apples and oranges is 248. Alrighty, do the apples again. Taking a little bit of care to make it look the same as the one above it, as much as I can. Now this time it's apples plus oranges. But you know what? We know oranges is the same as three groups of pears. So let's do that. That is the tricky part of this problem. If you realize that that little substitution, nice little math term there, see, that's the same now as apples plus oranges. And we know that total is 248. All right, ready for the big finish here? Look at this. If I do that, we know that between those lines represents the number 184. 184. So what about this little section right there? Well, we know it's 248 all the way out to the end. So that would be right, 248 minus 184. $64. And that's equal to 2 times the number of pears. So what's the number of pears? Must be 64 divided by 2. Ta-da! That's how many pears there are. And yippee skippy, we did it.